please, with the zero of the polynomial. Okay. Then the next thing, we are going to look at the end behavior. When we say the end behavior of the polynomial, we simply mean that as x goes to infinity, what happens to polynomial? Or as x becomes very large, what happens to the polynomial? So when you have a general term of a polynomial, which is axn plus an minus 1 x minus 1 up to the constant, which I have explained to you that it can be anything. So if n becomes very large, what happens to the polynomial? It becomes, oh sorry, if n becomes very large, what happens to the polynomial? That's what we are coming to investigate. So if you can look at here, we have this function p of x, which is the general form of the polynomial. Then we bring xn out. So when we bring xn out, we are going to have x an minus 1 over x, because when you multiply this one by this, we get the same thing. Then, please, any questions on this substitution? Any questions on that substitution? Yes, Zulu.
Yes, sir. Can you please explain how they did it, sir?
No. Okay, let me simply write is that like maybe we have 2x squared, né? 2x squared plus 5x plus 6. Then they bring x squared out. So once they bring x squared out, here will be 2. You see that? Then here will be 5 over x. So that when I multiply this by this x will cancel it. I also have x. You see that? Then here will be 6 over x squared. Can you connect the two now?
Yes, sir.
That's what I did.
Yes, sir.
Please, any questions again? Okay, let's go on. So we know that these terms, 1 over x, 1 over x squared, 1 over x minus 1, 1 over x, if x becomes very large, they will all go to 0. Can we all see that? Can we all see that? Can we see that these terms here? Let's look at it from the previous one. Can we see that this side? Look at this side. A minute. Let's look at this one. Can we see that as x becomes very large, they all go to 0? Can we see that? Can we see that?
Yes, sir.
Who cannot see that? So that as x becomes large, very large, p of x, it will be left with only an xn as x approaches either positive infinity or negative infinity. All this side will go to 0 because it will be a very large number dividing. So it will eventually go to 0. Can we see that? Can we see that? Can we see that?
Yes, sir.
Okay, good. Then let's so that is why here you see that all of this will go to 0 because as x becomes large and the constant and because these are constants, the whole of this will approach 0. So as x becomes very large, a n x n y will be equal to a n x n. Have you seen that? So we know that a n as x becomes very large, this thing will approach either negative infinity or positive infinity. Have you seen that? So that's why on a polynomial, when it's like this, as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y also approaches negative infinity for a polynomial. Can we, can we see that?
Yes, sir.
Yes, sir.
Okay, good. Um, so let's go on. Now the next one, let's start. The next thing is that we are going to try to sketch graphs of a polynomial. So here we have y equals to x minus 2 all cube plus 5. Now we know that the original cubic graph is like this. Have you seen that? We already know the endpoint that as x approaches infinity, y positive infinity, y will also approach positive infinity. And as x approaches negative infinity, y will also approach negative infinity. So now, when we have a graph y equals to x minus 2 all cubed, from the class we had on unit 2, or is it unit 3, we will see that this graph, the original graph is like this. But here, which is y equals to x cubed, then we can see that this graph, x minus 2, they have subtracted from the x minus 2. So it will move to the right by 2 units. Then it will move up by what? 5 units. So this 0.00 will come here to 3, 2 and 5. Have you seen that? It will move to the right by 2 units and move up by what? 5 units. So you can always plot and plot the translation graph. Please, any questions there?
No, sir.
Okay. Then let's go to the next. Now sketch the graph f of x equals to x cubed minus 4x. Now to sketch this graph, we have to note that this graph we have f of x equals to x cubed minus 4x 4x. Now, this graph, we know that the original graph is y equals to x cubed. You see, so here we can bring x out, then we get x squared minus 4. Now, if we can look at this graph, we can see that it is not easy for us to translate using the original. You understand me? Can we see that?
Yes, sir.
Okay, good. It will not be easy for us to translate using the original graph, but at least we can easily find the zeros. That if we bring x out, then we get x squared minus 4. 4 can be written as 2 squared. Then here we get difference of 2 squares, x minus 2 and x plus 2. X plus 2. So we can see that our roots will be x equals to 0, x equals to 2, and x equals to minus 2. Then we know the end behavior of a polynomial, that as x approaches positive infinity, y will approach positive infinity. Have you seen that? And as x approaches negative infinity, y will approach a negative infinity. Then clearly this function will clearly be an odd function. And we know that an odd function is symmetric on the origin from what we did in Unit 1. But to draw this graph, now we know we function. Let me please. Let me function. Okay, good. Okay, let's go on. We know the end function, but here too, to be able to draw the graph correctly, we are going to use the table method. Is that clear? To be able to draw the graph correctly, we must use the table method from Unit 1. So if you didn't get Unit 1 correctly, you must go and revise. But I will see what I'm going to be able to do. So to plot this graph, we know that you must get your table 1, 2, 3, 4. I hope it will be enough. Then I join like this. 1, 2, 3. So I know that my endpoints or my endpoints was minus 2, sorry, was minus 2, 0, and 2. So I can put minus 2 here. I can put 0 here. That means that I must draw more shapes. let me see, I'll need 1, 2, 3, 4, 5, 6, 7. Please, let me draw it again. I will need one. Okay, now let's look at it here. It's here. So I know that I have -2, 0, and 2. So my points, my factorization was x minus 2, x plus 2. So I know that here is when x is between negative infinity, when x is between negative infinity and 2. Here is when x is between negative infinity and I can pick any number like -3. Here will be negative. Here will be negative. Here will be negative. Negative, sorry, here will be negative. Here is going to be negative, and here is going to be negative. Negative times negative times negative. What's the problem here? When x equals to when I pick a number like -3, yeah, here will be negative, negative, negative. So negative, negative is positive. Negative again, I'll get negative. So here will be negative, as it will be negative. Then at -2, here will be negative. Second one, x minus 2, if I put it here, it will be negative. But x plus 2 will be positive, 0. Negative times 0, I'll get 0. Then between -2 and 0, I can pick a number like 1. Here, if I pick a number like between -2 and 0, I can pick any number. Let us say -1. So here will be negative, here will be negative, here will be positive. Negative, negative, positive. Then I'll get positive. Then between 0 and 2, I can pick a number like 1. Here will be positive. When it's x minus 2, it will be negative. When it's x plus 2, it will be positive. So positive, negative, positive, I'll get negative. Then at 2, x will be positive. When I put 2, my x minus, when I put 2, I'll get 0. X plus 2, when I put 2, I'll get positive. So positive, 0, positive, I'll get 0. Then x greater than 2, I can pick a number like 3. Positive, x minus 2 is positive, x plus 2 is positive. So everything will be positive. So I also know that as x approaches negative infinity, my graph will approach negative infinity. But anywhere less than -2 is also my function is negative. So I will start from negative up to 2, -2. At -2 is 0. Then from -2 to 0, my graph is positive, as you can see from the table. Then from 0 to 2, my graph is negative. At 0, the graph is 0. Good. Then from 0 to 2, my graph is negative. Then from 2 to positive infinity, my graph is positive. So that's how we draw the polynomial graph. Please, any questions on how this graph was drawn? Any questions on how this graph was drawn? Please, is the graph clear?
Yes, sir.
Okay, good. Then let's look at the next one. Now, the next one, we have a graph saying that f of x equals to x minus 2 all cube minus 5, 4x minus 2 all minus 2 plus 5. Please, you have to know that for a graph, you can use different approach to draw the graph. So this graph, the way it has been written, there is a possibility that you can do what do you call it, a translation. So if you can look at this graph, the original graph is going to be y x cube plus, what do you call it? Y x cube 4x. Y x cube plus 4x. Then you can easily use our factorization. Oh, sorry. You remember that we have already sketched this graph. We sketched a graph like this. If you remember, we sketched a graph like this. Y equals to x cube minus 4x. We just get that graph. Then we got this graph. You see, so if you can look closely at this graph, it's just like bringing x out. Then we got okay, no. If you can look at this graph, you can see that they have subtracted 2 from the x. Have you seen that? Then they have added 5 to the function. Have you seen that? So this is just like a graph that is going to move to the right by 2 units and move up by what? By 5 units. Can you see that? So we can always do a translation. If you know one graph, you can translate and get another graph. Please, any questions? Please, any questions? Please, any questions?
No questions, sir.
Okay, good. Then last time in class, yes. Is there any questions? Okay, no. Last time in class, we also showed you how the expansion of graphs. For instance, if you have x squared, it is small. As when it's an even function, when it's an even, what do you call it? When the exponents are even numbers. So as the even numbers begins to increase, the base of the graph begins to expand. As the even numbers begin to increase. And for all functions to be the same thing. All graphs, all with the functions and polynomials with the exponents, the highest order being odd numbers. It is like that, like this. So as the odd numbers begin to increase, the base of the graph also begins to increase. So, for instance, if you have 1 over 2 x exponent 7, now as you know that when we multiply the whole function by half, the graph, if it is by a whole number, the graph begins to shrink. If it is by a fraction or a number between 0 and 1, the graph begins to expand. So that's why we have y equals to x exponent 7. We have the graph like that. But once we multiply by half, the graph begins to expand. But if the number is between 0 and 1, the graph will begin to expand. If it is a whole number, the graph will begin to, or if it's a number greater than 1, the graph will begin to shrink. And let us also not forget that if the number is negative, it's also going to reflect on the y-axis. Any questions? Yes.
What happens to the graph if it has an odd exponent? Can
But
you
this one
please
has got an
repeat
odd
it?
exponent.
Yeah, if it has an odd exponent.
Yes. So let us say, and the first odd polynomial it will be like remember that the first one will be is infant. So this one is x cubed. You see. So if it's x5, then the base will expand a little bit. You see that? Then here will be x5. If it is x7, the base will expand more. Have you seen that? The base will expand more. If it is x7, it's in that order. Have you seen that? Always the base expands.
Okay,
Yeah.
I guess.
Okay, good. Any questions? Again. Any questions again? Any questions again?
No questions from. Oh,
Okay, good. Then let's go on.
okay.
Let's go on to the next one. So the same thing to for an even number. We have done this in unit 2 already. Have you seen that? If you multiply by a whole number, the will begin to shrink. Have you seen that? If you multiply by a fraction between 0 and 1, the graph will begin to expand. Have you seen that from the original function? Uh-huh. Rainy, what's the question?
I just saw the link reply one to them like
Can we go? Can we go on, please?
We can go on, sir.
Okay, good. So you must know the dynamics of how the graphs behave. You must know the dynamics of how the graph behave. And here we have different types of graphs. Now, if your highest order is 2, you have only one vectors. If your highest order is 3, you have 2 vectors. If your highest order is 4, so always the vectors or the turning points is always n minus 1, where n is the highest order. That is also one general behavior you must know about a graph or a polynomial. That's also one behavior you must know about a polynomial. Any questions? Can we go on?
Yes, sir.
Okay, good. Then we also remember that we also did odd and even functions. Please, we have to. Can we all see that when y is equals to when the power is an even number, when n is even, the function is always an even function. And when we have y equals to xn, when n is odd, the function is always an odd function. Can we all picture that? Remember that an even function, f of x equals to f of minus x, and an odd function, f of minus x equals to minus f of x. Can we all see that? Then we also have to note that, for instance, let us take a polynomial y. If I have y, sorry, if I have a polynomial y equals to 2x squared. So in this case, my an is positive. Remember that from back from your high school, your graph was similar. Okay, no. Let me just do it again. Y equals to 2x squared. Your graph will seem out like this. Then y equals to minus 2x squared. Your graph will look like this. It's going to be like this. Can we all acknowledge that, or do you all remember that? Your graph will be angry.
Yes, sir.
Now you can see that no, if your A is positive, né, for an even function, when you have an even function, as x approaches positive infinity, your y will approach positive infinity. As x approaches negative infinity, your y will approach negative infinity. Can we see that? Then if your A is less than 0, as x approaches positive infinity, your y will approach negative infinity. As x please let me start again. See that here, as x approaches positive infinity, your y approaches positive infinity. And the same thing, as x approaches negative infinity, your y will still approach positive infinity. Then when you come to what do you call it? When you come to when a is negative or the coefficient is negative, as x approaches negative infinity, your y will approach negative infinity. And as x approaches positive infinity, your y will still approach negative infinity. Can we all see that when n is even? Is there any questions there? Is there any questions there?
No questions, sir.
Okay, good. Then let us look at when it is odd. You see, when it is odd, let us say when I have y equals to x cubed, my graph will look like this. Sorry, like this. Then when I have, let's say, y equals to negative x cubed, this time it's going to go like this. So here, if the highest order or your n is odd, as x approaches positive infinity, your y will approach positive infinity. And as x approaches negative infinity, your y too will approach negative infinity. But if your coefficient of the highest order is negative, as x approaches negative infinity, your y will approach positive infinity. And as x approaches positive infinity, your y will approach negative infinity. Any questions there? Any questions there? Yes.
No question.
Can you please repeat,
Because
sir?
Come again.
Can you please repeat?
You see here, when you have x cube, your graph looks like this. Can you see that? Now you can see that as x is approaching negative infinity, your y is approaching negative infinity. Can you see that when coefficient of the highest order is positive? Can we see that?
Yes, sir.
Good. Then as your x approaches positive infinity, your y also approaches positive infinity from here. Can we see that?
Yes, sir.
Then when we come here, as x approaches, when the coefficient of your highest order is negative, that's less than 0. As x approaches positive infinity, your y approaches negative infinity. Then as x approaches negative infinity, your y approaches positive infinity. And that is all that they have done here.
Oh, I see it now.
It's clear now?
Yes, sir.
Okay, thank you. Please, any questions again? Please, any questions again? Now, the next one says that determine the lowest possible degree of the polynomial as well as the sign of the leading coefficient. Okay, so number one, who can tell me the lowest, what can be the lowest degree? Remember, it has got two vectors. What will be the lowest degree? Who can tell us? Who can tell us the lowest degree? Who can tell us the lowest degree of number one? Yes. Who can tell us the lowest degree of number one? I'm waiting. Who can tell us? Yes, Abelo.
It's three.
Is how much?
It's three.
Good, it's 3. Because we have got two vectors here. 1, 2. Have you seen that? Then what is the sign of the leading coefficient? So when we look at the odd function here, we see that as x goes to positive infinity, y goes to negative what? Infinity. And as x goes to positive infinity, y goes to positive infinity. So obviously it will be here. You see that? So the sign of the leading diagonal, or sorry, the leading coefficient is going to be what?
So
The
which
sign of
graph
the
are we looking at?
you said
Which graph are we looking at?
number 1, 4.1.
Did Sabelo just make up that number or?
Can you come again? Can you repeat what you said?
No, sir, it's okay. I figured it out.
Okay. So, what will be the sign of the leading coefficient? What will be the sign of the leading coefficient?
It will be positive.
Yes, it will be positive. Good. Now, number 2, what is the highest order or the lowest possible degree of this polynomial? Number 2, what will be the lowest possible degree of this
Like 5.
polynomial? Is that not 5? I don't think so.
Four.
It's going to be 4. Can we see that? Good. Then, can we all see it's 4? Yes, Zulu.
How did you get 4, sir?
Because the vectors is 3. Yes.
Yeah, I see it, sir.
Sorry, sir, I didn't get that.
Because the vectors or the number of turning points there is 3.
Oh, okay.
Any questions? Any questions?
So if you want to determine the degree, you must look at the number of vectors.
And remember that right from the beginning, I told you that the degree, when you know the highest order of the polynomial, the degree is always n minus, the number of vectors is n minus 1 the degree. If the degree is n, the number of vectors is n minus 1. I told you that from the beginning. Have you seen that? Hello? Can you hear me?
Yes, sir. Yeah, I can hear you.
I told you that from the beginning. Have you seen that? That if
Yes,
the degree is n, the number of turning points will be n minus 1.
yes, sir.
So here, if the degree is, if the number of turning points is 3, it's enough for you to know that the degree will be 4. Can we see that?
Mm.
Can we see that?
Okay. So in number 2, there are 3 turning points.
Mm-hmm.
So you say 3 minus 1 or 3 plus 1?
Look, if the degree is, look, if we have y equals to x squared, then y equals to x squared. If you have y equals to x squared, now you are going to find out that the graph will look like this. You see that? So we have only one vectors, one turning point. Have you seen that?
Yes, sir.
With and so now if the turning point is 1, the degree is 2. Can you see that?
Oh, yes, sir.
If you have x cubed, it's like this. If you have x cubed, it's like this. Like the graph will look like this. Now, this one is y equals to x cubed. The degree is 3, but the turning points are 2. Can we see that?
Yes, sir.
Good. So that's all that we are doing here. So here the turning point is 3. So it's enough for you to know that the degree will be 4. Can we see that? Can we see that?
Yes, sir. We can see that.
Okay, good. Now the next thing, is the leading coefficient the sign, is it a positive or a negative for number 2? And why? The sign for the leading coefficient, is it a positive or a negative? And why?
Looks like negative.
According to me, it looks like positive. Look at it very carefully. As x approaches negative infinity, let's look at positive for even. As x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches positive infinity. So to me, it looks like it's positive, unless you also have a different explanation. Can we all see that the sign of the coefficient is positive?
No.
Now, did you understand this? Did you see we are going step by step. So if we are at a particular place and you don't understand and you make me move on, you always draw us back. That's why I always make sure that everybody understands before I move on to the next one. Now, look at here. Look at here. They are saying that if the leading coefficient an is positive, as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y still approaches positive infinity. Then, if the sign of the leading coefficient is negative, as x approaches positive infinity, y approaches negative infinity. And as x approaches negative infinity, y will also approach negative infinity. So if you look at here, you can see that no, as x is approaching positive infinity, negative infinity, y is approaching positive infinity. And as s is approaching positive infinity, y too is approaching positive infinity. Can we see that?
Yes, sir.
So we all agree that the sign of the leading coefficient is positive.
Yes.
Okay. So the third one, what will be the highest order?
6.
6. And what will be the sign of the leading coefficient? Or the leading coefficient? Yeah, the sign of the leading coefficient.
It's less than 0.
You said what?
Negative.
Yes. You can see that the sign of the leading coefficient is negative because as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y still approaches negative infinity. Can we see that?
Yes.
Can we see that? Can we see that?
Yes.
Now, what about the last one? What will be the degree?
3.
3. And what is going to be the sign of the leading coefficient? Positive or negative?
Positive.
No, I don't think so. I don't think so.
Negative.
Can you see it's negative?
Oh yeah.
Can you see it's negative?
Yes.
Okay. Please, any questions? Please, any questions there? Please, any questions there? I'm repeating, any questions before we go on?
No question.
Okay. Now, the next one is here. So now, when you are asked to sketch a polynomial, from all that we have done, before you can even draw the polynomial, you should be able to know so many things about the polynomial. Have you seen that? One, it is x, the highest order is x cubed. So or the order is x cubed, sorry. So you can clearly see that the turning points are going to be 2. Can you see that? Then we can see that the leading coefficient is 1. If the leading coefficient of the polynomial is 1, or that means that it's positive, it tells you that as x approaches negative infinity, y will approach negative infinity. And as x approaches positive infinity, y will approach positive infinity. So you must always meet the, how do you call it, the end behavior of the graph. Then apart from that, then we can now draw our graph. We can find a table. Clearly, if you factorize this polynomial, you are going to get x, x plus 1, x minus 1. That means that our point will be x equals to 0, x equals to minus 1, and x equals to 2. Then we can draw the table. Then we can easily draw the graph. That we know that as x approaches negative, y approaches negative infinity. At negative 1 is 0. Between negative 1 and 0 is positive. At 0 is 0. Between 0 and 2 is negative. At 2 is 0. Then at greater than 2 is positive. So that's how we draw polynomial graphs now. Can we all understand what has been done there? Can we all understand what has been done there? Can we all understand what has been done there?
Yes, sir.
Oh, can you please repeat, sir?
I didn't say anything. The whole thing is here. I just want to ask whether you understand what is on the screen. Do you all understand what is on the screen?
No, sir. Can you please repeat?
Um, Do you understand this factorization? It is a little bit problematic. It is a little bit problematic to me if you cannot still understand the table. It is a little bit problematic to me because this thing was done in unit 1. Have you seen? And we have also done examples. You never said you didn't understand, but let's still go on. Now, do you understand this factorization? I have circled.
Yes, sir.
Okay, good. And do you understand that the endpoint is x equals to 1, x equals to 0, and x equals to minus 1? The
Yes.
point. Okay, good. Then this table is from unit 1. Have you seen that? Here is when x is between negative infinity and negative 1. Here is when x is equal to negative 1. At this point is when x is between negative 1 and 0. At this point is 0. At this area is when x is between 0 and 2. At this point is 2. And at this point is between when x is between 2 and infinity. So my question is that, do you understand this table?
Yes, sir.
No.
No.
Okay, somebody says no, so you must go through. Now, can you tell me where exactly you don't understand? Where exactly on the table don't you understand? Because here, you can pick any number between negative infinity and negative 1, like negative 2. If I put negative 2 here, it will be negative. If I put negative 2 here, it will be negative. If I put negative 2, it will be negative. Negative times negative is positive, times negative, I get negative. Then at minus 1, if I put minus 1 in place of x, it will be negative. If I put minus 1 here, it will be 0. If I put minus 1 here, it will be negative. Negative times 0 times negative will be 0. Between negative 1 and 0, I can pick a number like negative half. If I put negative half here, it will be negative. If I put negative half here, it will be positive. If I put negative half, it will be negative. Negative times positive times negative, I will get positive. Then at 0, if I put 0 here, I'll get 0. If I put 0 here, I'll get positive. If I put 0 here, I'll get negative. 0 times positive times 0, I'll get 0. Now, between 0 and 2, I can pick a number like 1. If I put 1 here, I'll get positive. If I put 1 here, I'll get positive. If I put 1 here, I'll get negative. Positive and negative, I'll get negative. Now, at 2, if I put 2 here, I'll get positive. If I put 2 here, I'll get positive. If I put 2 here, I'll get 0. Positive times 0, I'll get 0. Then here, greater than 2, I can pick a number like 3. If I put 3 here, I'll get positive. If I put 3 here, I'll get positive. If I put 3 here, I'll get positive. Positive, I'll get positive. So what's wrong? This thing was done far back as unit 1. So it is very problematic if this table is still problematic to you. Any questions on the table again?
Okay, I
see.
get it now. I get it now.
Okay, good. So now we can see that the end point, we know that as x approaches negative infinity, y will approach negative infinity. So the graph will start from negative infinity. Then we know that between negative infinity and negative 1, the graph is negative. So it's below the x-axis. At negative 1 is 0. So that's why we have 0. Between negative 1 and 0 is positive. At 0 is 0. Now, between 0 and 2, it is negative. That's why we have negative. At 2 is 0. Between 2 and positive infinity is positive. That's why we have positive. Then we know that the end behavior shows that the graph will go to positive infinity. Any questions there? Any questions there? Any questions there? Please, any questions there? Or can we move on? Can we move on?
No question, sir.
Okay. So the same for here. I was saying that. Now, if you can look at the next question. Oh no, we have done this already. Now here we have got a function with an even. Have you seen that? Now the what do you call it? The highest order is even. Now you can easily factorize it. This back from first semester, unit 1. Now you can easily bring the common factor out, which is x squared. You see that? Then you factorize x squared minus 3x plus 2. We have x minus 1, x minus 2. So please, you have to know that this factorization is very crucial. Because if you don't take your time and get this factorization wrong, everything that you do is nonsense. It will be wrong. So is there any problem with the factorization? Is there any problem with the factorization? Is there any questions with the factorization? I'm repeating myself again. Is there any questions with the factorization?
No question,
No.
sir.
Okay. Then from there now we know that our endpoint will be x equal to 0, x equal to 2, and x equals to 1. From the zeros of that will be the zeros of the polynomial. Then we still come use the table method. Starting from we go in ascending order. So negative infinity to 0, 0. And also we have to know the endpoint of this polynomial. Remember that this graph is even and the leading coefficient is positive. So we have to know the endpoint that as x approaches negative infinity, y will approach positive infinity. And as x approaches positive infinity, y will also approach positive infinity. So you need to know the behavior of the graph. Is there any questions in the end behavior of the graph? Is there any questions with the end behavior of the graph? Is there any questions with the end behavior of the graph? Please, I'm repeating myself again. Are there any questions with the end behavior of the graph?
No question.
No, sir.
Okay, then now we have a table. I don't think I must explain the table every time. Do you understand the table?
Yes, sir.
Okay, good. So now then we can easily draw the graph. Now we know that the end behavior as x approaches negative infinity, y approaches positive infinity. Then we know that from negative 1 to 0, the graph is it is positive. Have you seen that? As 0 is 0. Between 0 and 1, the graph is still positive. Can we see that? From the table. Can we see that? Can we see that? Can we see that?
Yes.
Then between 1 and 2, the graph is negative. At 1 is 0. Between 1 and 2, the graph is negative. At 2 is 0. Then between 2 and positive infinity, the graph is positive. Can we see that? Can you link the graph in the table? Can you link the graph in the table? I'm repeating myself. Can you link the graph in the table?
Yes.
Yes.
Okay, good. So if all of you can link the graph in the table, then you can go and do this exercise 4.2. The answers can be found on BB. All the answers can be found on BB. And also, the next thing that we are going to talk about is the zeros of the polynomial. I think during the first semester, we tried to learn how to divide a polynomial. How do you say? So I think, and here we know we use divide, multiply, subtract. We use divide, multiply, subtract. Now, we can see that, so here, we start when we want to divide this polynomial, we take 2x, divide by 8x cubed. We get 4x squared. Then we multiply 4x squared by 2x squared minus 2. We write it here, we subtract. We get minus 10x squared plus 27x. We divide 2x by minus 10x squared, we get minus 5x. We multiply, we get minus 10x squared plus 15x. Then we subtract, we get to this one goes to 0, we get 12x minus 8. Then we divide 2x by 12x, we get plus 6. Then we multiply, we get 12x minus 80. Then we put it, then we subtract, we get 0. Can we see that?
Yes.
So that is how, and once you get 0, that will tell you that x equals to 2 over 3 is a 0 of the polynomial. Have you seen that? Once you get 0, that means that 2x minus 3 is the factor. Can we see that? So here too we can easily divide. So remember that I told you in the first semester that when you have something like x cubed minus 1, to make things easier for you, write everything, write all the terms until you get a constant. Here you write it x cubed, there is no x squared, so that means that the coefficient is 0, plus 0x squared plus 0x squared 0x plus 0x minus 1. Then the same procedure, divide, multiply, subtract. When you divide after and your remainder is 0, that means that x minus 1 is a factor of the polynomial. So here x will divide x cubed to x squared. Then we multiply, we're going to get x cubed minus x squared. Here is 0. 0 minus x squared, we get x squared. Then here 0x, we get 0x minus 1. Now, this x will cancel this x squared to what? X. X times x, we get x squared. X times minus 1, we get minus x. Then x squared minus x squared, we get 0. 0 minus 1, we get positive x. Then this minus 1 will come down. X to plus 1. 1 times x, we get x. 1 times minus 1, we get minus x. Then this one will go to 0. This one will go to 0. Is that okay? Division of the polynomial, is that okay? Is that fine?
Yes.
Yes, sir.
So that's how we divide a polynomial. So I think the rest of the topic is about division of the polynomial, and we have brought the unit for unit 3 to an end. So you should practice on how to sketch these graphs. Have you seen? The answers are at the back of the book. So that will be the end of the class, because if you understand it, you should be able to draw any graph. Yes.
So I wanted to ask if the test is open.
Yes, I wanted the class to end, then I will inform you about the test. Please, the test has been postponed to.
Oh,
I'm going to send you the details.
yes,
I'm going
sir.
to send you the details now. But the test has been postponed to Wednesday. Is that
Yes, sir.
I have sent the details on the WhatsApp group. You can also find it on Blackboard. Is that clear?
Yes, sir.
So that will give you time to revise this unit before you write the test on Wednesday.
Yes, sir.
Okay. Please, any questions again? Please, any questions again? Now, secondly, once I submit your marks, I will not change anything. That's why I've told you that if you want to view your script, come and view it. Because the moment I submit the script, you will not even see it. I will not even show it to you again. And I will not change anything. So it is still open from 2:30 to 3:30. You can come and check your marks vis-a-vis the memo. Is that clear? Is that clear? I'm repeating, is that clear?
Yes, sir.
Okay, good. So that means that please, the onus lies on you to go and revise before you class test, which are postponed to Wednesday.
Yes,
So
sir.
if in the absence of no questions, we are going to bring the class to an end now. Okay, thank you very much. Good luck in your test. And those in
Thanks.
group 2, you have to know that our lesson starts tomorrow. Yes, it starts tomorrow. Those in 2. Thank you
Yes, sir.
very much. Bye-bye.